Hi guys, so this is a priority selector. It will be a part of the brain circuit that we are building. So basically a priority selector checks two inputs, A and B, and it's going to give a priority of one input over the other depending on how you have set your circuit to behave. Yeah, so this is basically this will be a demonstration to show you how the brain will start making its own decision based on what you have set or what you want it to do. So my priority selector right here, it has two inputs, input A and input B, which are going to be these two switch number 1 and switch number 2. They are going to enter the circuit, and the circuit will decide how to implement them. So if I turn on the first input A, you can see the blue LED is on. So this just like saying I'm giving you only one task, or as humans, let's say this is the task number 1 is eating, and task number 2 is sleeping, or hungry. Task number 1 is hungry and task number 2 is sleepy. So I'm hungry. So if I'm hungry only, then I'm going to eat. That's basically what I'm going to do. If I turn on task B, then I'm sleepy. So if I'm sleepy, then I'm going to go to bed and sleep. That's basically direct. What happens if I turn on both inputs? So I have two thoughts in my head. I'm hungry and at the same time I'm feeling sleepy. So what will I do? So now the brain turns into let me reason and think what is more important over the other. If I press this button, which is the think button, I'm going to call it think button, then blue LED turns on. Okay, blue LED turns on and then green LED turns on. So let's do that again. Blue LED turns on, then green LED turns on, and these two LEDs are timed. So if I want more time to LED B more than LED 2, then I just vary these two port meters. So this is basically showing you. So if I want, let's turn time to more or less to LED 1. So I'm just going to do that. As you can see, blue LED turns on the short amount of time. Let's turn it off further. Now it's going to be very fast. You can see it turns off very fast. I think green LED is given more time because I've not touched its control. Let's turn it off even further. Then it's super fast. So if I'm hungry and I'm sleepy at the same time, so I'm going to eat first, then I'll go to bed later. So this is how the circuit this is how circuits operate when they have two tasks or more at hand. So they reason and they think which is more big in terms of priority or importance than the other, and then it implements that which is important, then goes to the other one when the first task is already done. So basically how the circuit operates, let's just explain how the circuit operates. So right here we have two inputs. Both of the inputs enter this first. This is an AND gate, enters the AND gate first. So once they enter the AND gate, they also enter an XOR gate. So the purpose of these two gates, this AND gate and the XOR gate, is to check when I turn on the input A and input B, then the XOR should give a 0 on this input, because right now the circuit has shifted to another circuit. So it basically cancels this front part of the circuit and gives the rest of the circuit chance to reason, because the tasks are more than or are special. So we can call it a special task when both inputs are on. So if it goes to this mode, this special mode, then it turns off this front part of the circuit and gives priority to this other circuit to decide what it will do next. So that's basically what these two ICs do. Right here we have the NOT gate. So the NOT gate checks the output of the NE555, first NE555, which is monostable mode. after checking the output, it gives a NOT to the green LED. So this circuit gives priority to blue LED first, then after it has gone off, meaning that the monostable will be off, so inverting that will be on, giving time to this other LED to be on. So this is basically priority. This is first stage of the priority, which checks this input A. Once input A is off, then it gives chance input B to be on as well, because we want to do both tasks, but we want to go in a specific direction. We start with a specific task, then go to the other task later when the first one is already done. These are the circuits here, are pretty simple. These two ICs are just to amplify the signals, because you can see we are using the outputs of different ICs to power the next IC. So like the first IC, right, like this NE555s, the first NE555 NE555, okay, this one is timed, is given power to, is connected directly to the power supply, but the next one is given, you can see here, this is the power. As you can see in the pin number 8, this is the power. So it comes from this is an amplifier, it's a buffer. So we are going to use it as an amplifier, which checks the signals from the output of this NE555 connected in bistable mode. So because this connection will be weak, the output will be weak, not enough to power the IC, so we take it to the amplifier to be amplified so that it can go back to the next IC. So this basically connection of amplifying signals. Also, the NOT gate right here is also amplified. You can see its power comes from this buffer also, which amplifies signals from the NE555 monostable mode to give power to this IC. So this is basically how the circuit operates, and this is the timing of the green LED, and this is the timing of the blue LED, and these are the controls. You can just use this two port meters to control the amount of time you want to give to one task over the other. If I turn more time to LED B, you can see it turns on for a bit long time. If I turn it on even further, then it becomes even longer. You can see it stays on for a long period of time, and when it turns off, it will find that green LED is already off, because the timing of green LED was off. It's a bit further compared to the blue LED. If you can just put it just right there in the middle, let's see. Okay, green LED is still intact. Let's turn on B again. You can see it stays for a long period of time and then finds green LED as it's powering off. You can see it finds green LED as it's powering, almost goes immediately off. If I turn the timing of the green LED to be shorter compared to blue LED, and it has a long delay in the middle, then the green LED might as well not even turn on, because you can see, because it's a bit, there's a big delay in the timing where this LED gives chance for the next LED to turn on. But if I can just put it just like there, then the delay is not as much as before. You can see the green LED now has a chance to turn on and turn off. So this is basically how a priority selector operates. So in how we are going to implement this in my circuit, you can put this circuit in let's say sensors. So the sensors, if the sensors all record high signals, let's say a temperature sensor and a light sensor, so the circuit prioritize to do one task, or to operate one operation more than the other. So if it's too hot and there's too much light, so it prioritizes, let's say, temperature, because it's the one that's more sensitive, which can interfere or ruin or damage the circuits. So it will prioritize temperature more than other sensors. So it's going to implement protective feature to protect it from the temperature, then it will go back to the other connection. So this is basically what this priority selector does. Hope you've learned. I've not yet drawn the schematic, but I'm going to draw the schematic and I'm going to share with you guys so that you can do this at home. So this is episode 2 of making the brain series, and I hope you've learned. Hope to see you next time. Goodbye.